There is an ant on the underside of a leaf, about a foot above the floor of a rainforest, holding on with its jaws. It has been holding on for hours, and it will hold on for days. There is nothing to eat on the leaf vein it has bitten into. It is not feeding, and it is not resting. If you turned the leaf over in the green half-light, you would see that the ant is dead, that its jaws are still locked into the vein with a grip that dying did nothing to loosen, and that a single pale stalk has pushed out through the back of its head and risen past the body it has emptied. The ant did not end up here by chance. The height is too consistent for chance. The leaf sits on the northern face of the sapling, where it holds the light for most of the day. The jaws went into the thick central vein and not the soft edge, and the bite came around midday, with the sun almost directly overhead. In this forest, thousands more have died the same way. Under leaves, at the same low height, turned the same direction, biting at the same hour, until the ground beneath certain trees is a quiet field of them. An hour before it bit down, this ant had been walking. A day before that, it had been doing the ordinary work of its colony somewhere in the canopy above, one worker among thousands, with no more of a future and no less than any of the rest. The thing that brought it down out of the high branches and held it to this particular leaf and closed its jaws as the sun reached the top of the sky, that thing was not the ant. Inside it, for the last 2 or 3 weeks of its life, there had been a fungus. The fungus had entered as a single spore, grown through the body as a slow tide of separate cells, and spread into nearly everything the ant was, all without the ant ever faltering or seeming unwell. We call it Ophiocordyceps. The ant had no name for it and needed none. It never once sensed the thing that was killing it. The fungus has no aim. This is the part the usual telling skips, because the usual word for what happens here is zombie, and zombie arrives carrying a passenger, the idea of a will, a controller, some small malice working the strings. There is nothing of the sort inside the ant. There is a fungus, and a fungus has no more intention than rust has. What it has instead is a history, and the history runs roughly like this. A fungus that fruits from a dead ant does better, leaves more of itself behind, when the body it grows from is in the right kind of place, high enough to rain spores down onto the trails where ants walk, damp and warm enough for the stalk to ripen. A body that drops in the wrong spot is a dead end. So across a stretch of time longer than there have been primates to watch it, the lineages whose chemistry happened to walk their hosts to a good place left more behind than the ones whose hosts died just anywhere. The precision is real. It simply isn't a plan. It is what was left standing after every clumsier version failed to spread. The ant, climbing to its death, did not know it was anyone's instrument. It was, that morning, just climbing. And the fungus did not know it was steering. Nothing in the whole arrangement knew anything. And out of all that not knowing came a result a watchmaker would envy. An animal walked to a precise height, turned to a precise heading, and made to bite at a precise hour, by something with no eyes, no brain, and nothing in it that could want. That is the thing worth sitting with tonight. Not the horror, though there is some. The stranger fact underneath it, that a process with no purpose anywhere inside it can shape something that looks, from any honest distance, exactly like purpose. Before we go on, one small thing. If a channel like this, slow, quiet, made for the last hour you're awake, is something you'd want more of, subscribing is most of how it keeps going. And there's a question worth leaving in the comments if you're so moved. When you picture a mind being moved from outside with no one at the controls, does it land as horror or as something stranger and nearer to home? The answers to that one tend to be better than almost any fact in this field. Your own jaw is most likely loose right now, the way a jaw goes slack when nothing is being asked of it. The ant's was like that too once. the same plain tool it used every day to carry food and cut leaves before its last hour turned it into a clamp that would not open. 3 weeks before the leaf, before the grip, before any of this, that ant was walking a trail it had walked 100 times, high in the dark of the canopy, carrying food back toward the nest. And on that trail, smaller than a grain of dust, something was waiting for the touch of its foot. The thing waiting on the trail was a spore, and it could not move. That is the first fact of the fungus's life, and every other fact bends around it. It is rooted. The dead ant it grew from was fixed to its leaf. The stalk that rose out of the corpse was fixed to the dead ant, and the spores that loosened from the stalk fell only as far as the still understory air would carry them before they, too, came to rest and stayed. Nothing in this lineage chases, and yet the one thing that lets the lineage continue is the single thing it cannot follow. A living ant, which is to say a small, quick, tireless animal that spends its whole existence in motion and has no reason on earth to linger anywhere near the dead. So the problem is as stark as a problem can be, and everything that happens to the ant grows out of it. How does a thing anchored to a corpse reach a thing that never holds still? The answer is not to hunt, but to wait in exactly the right place and to be there before the ant is. And the right place is not chosen by the fungus. It is drawn over and over every day by the ant. High in the canopy of a tropical forest in southern Thailand, where the whole sequence was first watched closely, and in the Atlantic forest of Brazil, where teams have gone back season after season since, on their hands and knees on the forest floor, mapping where the dead ants hang and where the living ones walk, a colony of carpenter ants keeps to its routine. Camponotus, if you want the genus, big, dark, unhurried ants, the kind you have probably watched cross a windowsill or a tree trunk without once wondering where they were headed. They were headed somewhere exact. Carpenter ants live and die by their roads. A forager leaving the nest does not wander. It moves along a line of scent laid down by the workers ahead of it, an invisible road painted in faint chemicals across bark and leaf and soil, and it lays down its own trace as it walks, so the road is redrawn and deepened with every passing body. What looks to us like undifferentiated forest clutter is, to the ant, gridded with highways it can read in complete darkness, each one only a few molecules wide and perfectly distinct. A single colony may be tens of thousands strong, and thousands of journeys a day pour along the same few centimeters of root and leaf edge, out to the food, back to the nest, out again, until the root is worn into the colony's habits as deeply as a path is worn into grass. The trail is the colony's memory and its bloodstream at once, the thing that lets a few grams of insect behave across a whole tree as one spread-out animal. It is among the most quietly effective adaptations natural selection has produced. It is also entirely reliable, and reliability to something that has to wait is the whole game. The waiting itself is almost nothing to watch. From the corpse above, over a span of days, spores come loose and settle onto the leaves and litter to either side of the busy line below. Most of them come to nothing. They land where no ant ever goes, and the lineage that made them simply ends there, unwitnessed. But a spore that settles within a body's length of the trail does something small and extraordinarily patient. It grows a second time, pushing up a stalk finer than a hair and holding at its tip a single new spore, beaded and sticky as fresh resin. And then it goes still, with the droplet held out over the path, and it waits. This second spore, not the larger one that fell, is the one that catches an ant. It can hold that pose, sticky and ready, for days on end. It is easy to look at that, a sticky spore poised on a stalk, set just where a foot will fall, and see a trap, something shaped to catch, but nothing shaped it to catch anything. The ants drew the line it waits beside, and they drew it for their own sake, for food and coordination and the steady life of the colony long before any single spore arrived to make use of it. The fungus never came up with a way to find ants. What persisted instead were the lineages that happened to fall at the edges of the ants' roads and happened to hold a sticky spore out into them and waited, while every lineage that landed somewhere emptier left less behind, and then nothing. The colony's one great strength, that its members go faithfully to the same places by the same routes, is, seen from the spore's side, only a door propped open. The faithfulness of the road is the way in. This has been going on for a very long time. The forager out on the trail tonight is the latest in a line of foragers reaching back without a single break, every one of which walked its road and mostly came home. The thing waiting at the road's edge belongs to a line just as old, running quietly alongside the first. Two unbroken threads, side by side in the same wet shade, for longer than there have been eyes like ours to find either one. On an ordinary trip, in the ordinary heat of an afternoon, the forager brushes the stalk. The droplet holds. The ant feels nothing, because there is nothing yet to feel, and it walks on, carrying now, against the side of its body, a passenger far too small to see. The spore lies flat against the ant's outer shell, the cuticle, which is armor and skin in one thin layer, the whole of the wall between everything the ant is and everything it isn't. You are lying inside a wall like that right now. It is the largest thing you own. All day and all night, it is met by the same kind of fine, drifting life that has just met the ant. Spores in the air you're breathing, on the pillow, on the backs of your hands, landing and being shed again without your ever knowing, because the wall holds and the conditions on your side of it are wrong for the things that touch it. The ant's wall is the same idea, built by the same slow process, and for almost all of the ant's life it has held just as well as yours. It is about to stop. And everything that matters from here happens on the far side of it, in the dark beneath the shell, on a scale where the forest and the road and the whole vast colony shrink away to nothing, and the ant's entire fate comes down to what a few cells do next. What a few cells do next is quiet and almost gentle. The spore, pressed flat against the shell, swells against it and begins to work its way through, partly by simple pressure, partly by chemistry, loosening a pinhole in the armor with the kind of enzymes a great many fungi carry, the sort that digest shell and skin. And then it lets down a single thread through the gap into the space beneath. That space is not solid. An insect is not packed tight the way we are. Under the shell is an open cavity washed through with a pale fluid that serves an insect for blood, its hemolymph, in which the organs hang and bathe rather than being knit together. The thread reaches that fluid, and there the fungus does something that, if you could shrink down small enough to watch it, would not look like an attack at all. It takes itself apart. Instead of spreading as a mat of fibers, the shape we picture when we picture a fungus, the white threads through old bread or leaf litter, it rounds itself off into single, separate cells, each one budding off more, and lets them go into the current. They drift and divide and drift on. Over days, a slow tide of single fungal cells, blastospores the word is, moves through the open body of the ant, carried on the same unhurried flow that carries its oxygen and its food, spreading down into the legs, through the thorax, into the spaces around the gut, doubling and doubling as they travel. The thread became a fluid. The invader became part of the bloodstream. There is a reason it goes about things this way, and the reason is the host. An insect is not defenseless. Its blood holds cells of its own that hunt for intruders, surround them, and seal them inside hardened capsules darkened with the same pigment that tans the shell. And a spreading mat of fungal threads is exactly the kind of large, fixed target those hunting cells are good at catching. A scatter of single cells drifting apart and dividing as it goes is a far harder thing to corner. But there is a second pressure underneath the first, and it is the one that shapes the whole strange patience of this fungus. It cannot afford to kill quickly. A parasite that brings its host down fast is, in this line of work, a failure. The lineages that announced themselves, that brought on fever and collapse, that stopped the ant where it stood, lost the very thing they depended on before they could use it. What remained, after all the loud ones had failed, were the quiet ones, the lineages that moved in without tripping a single alarm, that drew on the body's resources while keeping the ant alive and working because they depended on all of it running a while longer. This is closer to an occupation than to a wound. The lights stay on. The roads stay open. For 2 weeks, 3 weeks, 14 days and then some, the ant goes on being an ant while becoming, by slow degrees, something else as well. It would be easy to read that stealth, the single drifting cells, the hidden spread, as a trick unique to this one killer. It is nothing of the kind. The same answer turns up over and over in fungi that took up the killing of insects entirely separately, scattered far apart across the family tree. The white fuzz you sometimes find on a dead fly stuck in a window frame is a different fungus, a thing called Bovarea, with no interest in ants and no zombies anywhere in its story. And inside its own victims, it does the very same thing, dissolving into single budding cells that ride the blood. Another, grown in vats by the ton and sprayed across locust swarms, does it too. The problem of how to grow inside a living insect without being caught and killed by it has come up many times in many lineages with no contact between them and nothing resembling a shared plan. And it has, again and again, had only the one workable answer. Step back from the ant for a moment, because the thing happening inside it is not as foreign to you as it feels. You are also occupied. You carry, right now, roughly as many bacterial cells as cells you would call your own. In your gut, across your skin, a whole resident population you neither chose nor notice that lives off you and, in the better cases, earns its keep. And it runs deeper than guests. In every single one of your cells, powering the muscle that would turn this thought into movement, sits the descendant of a bacterium that was swallowed whole somewhere around 2 billion years ago and never let back out. You are not one clean thing. You never were. The difference between you and the ant on the trail is not that you are pure and it is invaded. The difference is the terms. What lives in you arrived, across an unimaginable stretch of time, at a truce. In the ant, there was never going to be a truce, only a use, and then an end. And so the days pass, and nothing on the surface gives it away. The ant leaves the nest and walks its road and comes back. It is met by its sisters and groomed and fed, mouth to mouth, exactly as it always was, because nothing about it has changed in any way they can read. It tends the brood. It takes its turn. By the end of those weeks, it is no longer, by weight or by simple count of cells, mostly ant. And from the outside, it is still, in every visible particular, completely ordinary. One worker among thousands, going faithfully about the work of the colony, full to its shell with another life. We reach, when we talk about this, for the word takeover, and the word does a kind of violence to what actually happens because it sounds like a hand closing over a set of controls, sudden and total. It is nothing of the kind. For most of 3 weeks, as you have seen, there is no sign at all, and when the change finally begins, it does not begin with the limbs. It begins with time. Somewhere in you right now, a clock is running. It is part of why your body has been growing heavier as you lie here, why the day's alertness has been draining out of you by slow degrees since the light went down. An internal cycle, close to 24 hours long, that has been keeping time in living things since long before there were animals to carry it. It is older than ants and older than us, one of the oldest inheritances there is. You are, at this moment, doing the most ordinary thing in the world with yours, letting it pull you gently down into sleep. The ant has the same kind of clock, running the same kind of day. And the first thing to come undone in it is that an infected ant loses its rhythm. The neat daily order of its life, out to forage when the others forage, back to the nest to rest when the colony rests, works itself loose so that the ant is active at the wrong hours, stirring when it should be still, slipping out of step with the thousands of sisters whose days still run on time. It touches them less, too. A carpenter ant's whole life is held together by small, constant contact, the brush of antennae, the passing of food from mouth to mouth, the chemical murmur that tells each worker what the colony needs and where, and the infected one goes quiet in that conversation. It gives less and asks less. It drifts toward the edges of the nest, and then, on some day near the end, it walks out and does not come home. What it does instead is wander. A healthy forager moves with plain purpose, out along a known line and back again. This one moves like something that has lost track of where it is. It leaves the roads entirely. It clambers over ground no forager would trouble with. One patient count found sick ants, crossing nearly twice as many leaves as their healthy nestmates, going nowhere in particular, by no route that holds together. Its footing comes and goes, and then it begins to convulse. Every so often a shudder runs the length of the body, hard enough to break the ant's grip and drop it off whatever it was climbing. It lands, rights itself, and climbs again, falls and climbs and falls and climbs. A small body driving upward through the fog of its own collapse, with a persistence that is difficult to watch and harder to name. That difficulty is worth being honest about. It is tempting, watching this, to tell it as a drama, the ant struggling, the ant confused, the ant losing itself. And it is worth being careful here, because it is not at all certain those words mean anything at this scale. An ant is not a small person. Whether there is a self in there to come apart, whether lost is a thing an ant can even be, are questions no one can answer, and it is wise to be wary of anyone who claims otherwise. There is a second caution too, and it matters more because it is about the fungus rather than the ant. We are inclined to read every part of this as a precise program, the parasite reaching in and pulling each string in turn. But a body 3 weeks into being eaten alive from the inside is, among other things, simply a failing body. Some of the staggering, some of the falling, may be no more authored than the staggering of any dying animal. The careful people who study this hold both possibilities open at once and do not pretend to know, movement by movement, which is which, how much of this is the parasite steering, and how much is only the wreckage of a host coming undone. And yet, for all that it looks like pure disintegration, for all that much of it may be exactly that, the wandering is not in the end without a direction. Watch enough of these ants in enough forests, and the randomness settles into something else. They are not only falling apart, they are, on the whole, climbing rather than descending, drawn toward a particular kind of place, and arriving there at a particular time of the day. The staggering is carrying the body somewhere, and where a body like this finally comes to rest is no small matter. It is the one thing on which the whole of those 3 quiet weeks inside the ant now turns. Where it comes to rest is a place described with such precision that the first time you hear the numbers, they sound like a mistake, as though someone has wandered out of biology and into engineering and forgotten to come back. The body is found, over and over, at around 25 centimeters above the soil. Not the canopy where the ant lived, not the ground, but a narrow band, low in the understory, roughly knee-high to a child. It is found, far more often than chance would allow, on the north-facing side of whatever it has climbed. It is found on the underside of a leaf, never the top. And the jaws are set, almost always, not into the soft flesh of the leaf, but into the thick cord of a main vein. Someone counted all of this. One of the papers that first laid it out carried the quietly perfect title, The Life of a Dead Ant, and it is full of the kind of measurements you take when a thing is too strange to trust to memory. Heights to the centimeter, compass bearings, the angle of the sun. The sun matters as much as the height. The bite does not fall at a random moment of the day. It comes around noon, the records gathering near the hours when the sun stands close to the top of the sky, some 80 degrees up near its daily peak, as though a clock no one can see has been counting down toward a single, fixed appointment. So picture the morning, for whatever the word is worth, at this scale. The staggering of the night and the early hours is nearly spent. Late in its last morning, the ant comes to a sapling and begins once more to climb. But this climb is not the falling and reclimbing that came before. This one holds. It works its way up into that low band of the understory. It moves, with no possible way of knowing it is doing so, around to the northern face. It walks out along a leaf and onto the underside, upside down now, the forest hanging above it and the floor below. And there, as the sun reaches the top of the sky, it stops. There is no struggle in the last moment, nothing that reads as fear. The jaws simply open and close on the cord of the vein and hold. That is the final thing the ant will ever do as anything you could call an ant. It is not dead yet. It will hang there, alive, for hours, held by its own mouth in the warm, wet shade while the day moves over it. And everything it does from here on is no longer an action, but a position. Hold on to how strange that is for a moment, because the strangeness is the whole point. The ant has no compass and no ruler and no clock. It cannot know which way is north, or how high 25 centimeters is, or that the sun has reached its peak. And yet the outcomes are exact. Whatever is producing this precision is producing it through an animal with no way to perceive a single one of the quantities being hit. None of it in any case is for the ant. It is for what comes next, and what comes next needs conditions as particular as a recipe. That low band of shaded north side air under a leaf holds a climate the fungus can finish its life inside, a temperature that stays day and night somewhere in the mid-20s Celsius, and an air so wet it is nearly at saturation. Higher up, it is too dry and too bright. Down on the ground, it is too crowded with other things that would eat a soft fungus alive. The proof that the spot is no accident is almost crude in its simplicity. When researchers moved the bodies, lifted them higher, set them lower, carried them out of that narrow band, the fungus growing from them faltered. Smaller stalks, fewer spores, or none at all. The ant has been walked on the last of its strength to nearly the only place in the whole forest where the thing inside it can come to fruit. And then there is the grip itself, which is its own small horror once you understand what it is. An ant's jaws are closed by muscles the way yours are, and ordinarily those muscles tighten and let go 1,000 times a day. In the dying ant, they do not let go. Something drives the jaw-closing muscles to contract far past their normal limit and to go on contracting until the fine internal machinery that ratchets a muscle shut is wrenched apart and ruined in the act. The result is not paralysis. Paralysis would be a muscle switched off, gone slack. This is the reverse, a muscle locked on, clenched past the point of return and broken in that clench, so the jaws are held shut by a contraction that can no longer be undone. When the ant finally dies, nothing loosens. The grip outlasts the life by days, because the thing holding the jaws closed is no longer anything the ant is doing. It has become structural. The body is now its own clamp. It is worth being clear about what was and was not built here, because the grip looks for all the world like a purpose-made anchor, a hold-fast designed to keep a corpse in place through wind and rain. Nothing of the kind was designed. The fungus grew the ant no new organ, no hook, no clamp. It took hold of a jaw that was already there, the same jaws the ant had used every day of its life to carry food, to cut, to grip a branch in the wind, and drove that ordinary tool to a single terminal extreme. The climbing, too, was already in the ant. Ants climb constantly and need no teaching. What the fungus has, in the end, is not an invention, but the seizure of things the ant already owned and already did. The death grip is only an ant's own grip, on an ant's own jaws, made permanent and put in the wrong place. The look of design is entirely on loan from the animal being killed. You are carrying much the same equipment. Along each side of your jaw runs a muscle called the masseter, one of the strongest in the whole body for its size, able to bring your back teeth together with a force you have almost no reason to use. Most nights, it simply rests. But a great many people, deep in sleep, use it anyway. They clench and grind in the dark, jaws working at nothing, driven by something beneath the self that has gone to sleep and left no instructions. They wake with aching faces and no memory of it at all. The ant's death grip is that same involuntary clench carried to its furthest imaginable end, a jaw closing not by the will of the mind that owns it, but at the urging of something that mind will never meet, which is the question the locked jaw leaves hanging, and it turns out to matter more than the height or the hour or the leaf. Something is reaching into those muscles and holding them shut. You would assume, anyone would, that an order like that must come from the place an ant keeps whatever it has by way of a mind. The head, the dense little knot of nerves behind the eyes, the obvious seat of the controls. It is where we would have put the steering. It is where, for a long time, everyone went looking. The assumption is so natural that almost no one thought to question it. To move a body, you take its brain. Every machine we have ever built that steers itself steers from a center. Every animal we have ever known runs its behavior out of the dense knot of nerve tissue it keeps in its head, and every zombie in every story we tell goes, without fail, for the brain, because the brain is so obviously where the self lives, and to own the body you must surely first own the self. So when biologists set out to learn how the fungus drives the ant, they did the obvious thing. They looked in the head. They expected to find the fungus there, threaded through the brain, rewriting its commands from the inside. What they found instead took years to credit. Finding it out was an act of almost obsessive patience. A team took an ant, frozen at the exact instant of its death grip, and cut it, not into a handful of slices, but into thousands, in sheets 50 nanometers thick, which is to say a slice so thin you could lay something like 1,000 of them across the width of a single human hair. They photographed every sheet in turn under an electron microscope and fed the whole stack into a computer they had trained to tell, in each grey image, which flecks were ant and which were fungus. Layer upon layer, the program rebuilt the inside of the ant in 3 dimensions, until the body could be turned in space and read almost down to the level of single cells. No one had ever looked at a hijacked animal this closely. What the reconstruction showed did not answer the old question so much as throw it out. The fungus was everywhere. It had spread through the head and the thorax and the legs. It lay packed against the muscles and, in places, wound directly into the muscle fibers, present in such quantity that, taken all together, the fungal cells made up around 1/10 of everything inside the ant by volume. And the separate cells were not separate. They had joined, linked to one another by short connecting tubes, each cell tied to as many as 6 of its neighbors, so that what filled the ant was not a scatter of invaders, but a single connected web, a body-spanning network laid over and through the animal's own workings. The thing on the leaf, one of the researchers put it, was less an ant with a fungus inside it than a fungus wearing an ant. And in the one place everyone had expected to find it, the brain, the knot behind the eyes, the seat of the controls, there was nothing, not less than elsewhere. None at all. The fungal cells crowded right up against the outside of the brain and stopped, banked around it without ever entering, as though the brain were the single room in the house the occupier never set foot in. The thing that had walked the ant down to the leaf and locked its jaws on the vein had never once touched the organ that, in any animal we understand, would have to be the place the commands came from. This is the finding that turns the whole story inside out, and it is worth standing still inside for a moment because it is genuinely strange. The fungus does not control the ant's mind. It goes around the mind altogether. It reaches past the brain to the muscles themselves and works them directly, the legs that climb, the jaws that close, the way a puppeteer moves a marionette by its strings rather than by reasoning with it. Through all of it, the ant may keep a perfectly intact brain. That brain is simply no longer the thing in charge of the body it sits in. The orders are coming from the meat. It is worth feeling here where you are running from. Everything you have done since you began listening, the small shifts of your weight, the breath you just took, the act of carrying this sentence to its end, has issued from a place a little behind your eyes, an organ of about 1.5 kilos that you have spent your entire life being. You could not lift a finger without it. You cannot form an intention that does not pass through it. As far as you have ever had reason to believe, that organ is not so much where you live as it simply is you, and the body is the thing it drives. What the ant shows, hanging upside down beneath its leaf with its mind left whole and idling, is that this arrangement, behavior flowing down from a single self in the head, is not a law of how bodies must work. It is one way bodies happen to work in the lineages we descend from. Take the brain out of the loop, drive the muscles from outside, and the body will still climb, still turn, still bite, with no one at all at home up top. And here the apparent genius of the thing quietly comes apart into something else. From a distance, the manipulation looks like a masterpiece of control, a parasite that has learned to fly another creature's mind. But no engineer handed the task of seizing a body would ever have built it like this. You would go straight for the brain. You would take the one part that already commands every muscle, and you would send your orders through it, cleanly, the way the animal's own nerves do. To skip the brain entirely and instead infiltrate every muscle in the body, one fiber at a time, stringing a whole separate network through the host just to move it. That is not elegant. It is a vast, redundant, brute force way around a problem with an obvious front door, which is exactly the fingerprint of the process that made it. Evolution did not sit down and pick the clever solution. It kept whatever happened to work, however backward, and what happened to work in this lineage was reaching the body without ever solving the brain. The thing that looks most like the work of a designer turns out to be the firmest evidence that no designer was anywhere near it. There is one last turn, and it is the coldest of them. The researchers suspect the brain is not merely spared, but kept, sustained, left running, because the fungus depends on the ant staying alive and able to perform right to the end. A dead ant cannot climb. A wrecked brain cannot find the leaf. So the occupier empties out the body around a control room it leaves the lights on in, moving the animal from outside while the original pilot sits on, intact and conscious and powerless until the final bite is done. Whether that sparing is in any sense deliberate is still an open question. What is no longer open is the shape of the puzzle. The fungus is not in the brain. It is in the muscles, and it is reaching them by some route that has nothing to do with nerves or commands or anything we would recognize as steering. And the question of what that route actually is, of how a fungus with no nervous system of its own can lay hold of another animal's muscles and time their every motion, is the hardest question in this whole story, and the one we are furthest from being able to answer. If the orders do not come down through the brain, then they come some other way, and there is really only one other way they could come. The fungus is sitting in the muscle. It has no nerves to send a signal along and no hands to pull anything with. What it has, and has in abundance, is chemistry. A fungus is a chemist of extraordinary range, pouring molecules out into whatever it grows through. So the reasoning is clean, and for the better part of 15 years it has driven the whole effort. If the fungus is steering the body chemically, then somewhere in the cloud of compounds it gives off, there must be the one that does it, the molecule that reaches a muscle and tells it to seize. The switch. Find the switch, and you have found how the trick is done. The hunt for that one molecule has become one of the more humbling stories in modern biology because the molecule keeps not being there. The leads have been real, and each has dissolved in the hand. There was a compound the fungus pumps out far more of when it has its host's brain nearby. A promising sign, except that its name is an unpronounceable string of syllables, and except that when researchers purified it and injected it into a healthy ant, the ant did nothing of the kind. Whatever the compound does in there, on its own, it is not the switch. There was ergot, the fungal poison that, in the wrong loaf of medieval bread, sent whole villages into convulsions and burning visions, whose genes, the ones that assemble it, blaze into life at the exact moment of the bite. And yet the poison itself has never actually been found inside the ant, only the genes that would make it, switched on and plainly busy. There was a relative of the toxins that drive grazing livestock into the staggers, that helpless loss of footing. Give a measured dose of it to a healthy carpenter ant, and the ant does slow and sway and lose its coordination, which felt for a moment like the answer, but it never climbs and never bites and never builds the grip. It is a fragment of the behavior and nothing more. And there is a toxin switched on more violently than almost anything else in the fungus at the hour of the bite, thousands of times above its resting level, a kind of poison kin to the one behind cholera. It is the single loudest chemical signal in the whole performance, and no one has yet managed to show that it does anything at all. It is worth noticing what kind of molecules these are. The suspects, again and again, are molecules of signaling, the substances nervous systems use to speak to themselves. The neurotransmitters. If the fungus is writing anything down in that muscle, it is writing in that alphabet, and it is an alphabet you are using at this very moment to read these words. The dopamine that colors what you want, the acetylcholine that carries the command from a nerve to a muscle every single time you move. These are not specialist tools of the human brain. They are ancient. They were already at work in living things long before there were brains to keep them in. And they run in the same chemical letters through the ant on the leaf and through you in the dark. Whatever the fungus is or is not saying, it would be saying it in a language older than ants and older than us, one that all three of us, fungus, ant and listener, have inherited from the same deep source. That is part of why the puzzle is so hard. The fungus is not breaking into a foreign system, it is speaking a tongue the body already speaks. And it is clearly saying something exact because of one experiment that is difficult to forget. Grow the fungus in a dish, and then set beside it a single dissected ant brain, and the fungus changes what it gives off. It tastes the brain, in effect, and adjusts. Set the brain of its natural host beside it, and it produces one particular suite of compounds. Set the brain of a different ant, one it does not normally infect, and the mixture shifts. Most of what it made for its true host, it stops making. Its output is keyed, chemically, to whose body it is in. So the control is real, and it is specific, and it is tuned to the host with a precision that ought to make the active ingredient easy to pull out and name. It has not been easy. So far, it has been impossible. The likeliest reason is the one nobody wanted, because it makes the problem so much larger. When researchers read which of the fungus's genes switch on at the instant of the death grip, the answer is not one gene or a handful. It is more than 1,000, well over 1,000 genes firing at once, the great majority of them found in no other fungus on Earth, unique to this lineage and this single act. There may be no switch, because there is no switch. Not one molecule, but a chord, a whole secreted orchestra played at the muscle, no single instrument of which is the melody. And here, a quieter possibility has to be allowed, the kind of caution the careful researchers keep close. Not everything in that cloud is necessarily a tool. A fungus eating an ant from the inside is also simply a fungus hard at its metabolism, and metabolism throws off molecules the way any furnace throws off smoke. Some of what we have spent years sifting may be exhaust rather than instruction, the byproducts of a body at work mistaken for the keys to a lock because we came to the cloud already certain that a key was in it. So the most truthful thing that can be said about how the fungus actually moves the ant is that we do not know. We can name the suspects, read the genes, watch the chemistry shift in a dish, and we still cannot say of the precise thing that walks an animal up a stem and locks its jaws, how it is done. The fungus arrived at this. Whatever arrived at means for a process with no one arriving at anything, somewhere on the order of tens of millions of years ago, and has been performing it without a flaw ever since. And we, who can read its entire genome in an afternoon, cannot yet name the move. There is no shame in that. There is only the size of what is still waiting to be found. But step back from the cloud of molecules for a moment, far enough that the chemistry blurs and a larger shape begins to show through behind it. Because every one of those compounds is the product of a fungal gene, and what we are really watching when the ant climbs is a handful of genes reaching out past the body that carries them and laying their hands on a body that is not theirs. That reach is the strangest thing in this whole story, and it has a name. The reach has a name, and it is worth slowing down to earn it, because the name settles a question this whole story has been circling without quite asking aloud. For 6 chapters, we have watched something that behaves, at every level, like a piece of design. A body walked to a measured height, a jaw shut at a measured hour, a spot matched to the exact degree of warmth a fungus needs. And every time we have leaned in to find the hand behind the design, the flaw has dropped away. No aim in the fungus, no plan, no order coming from any brain. The design will not resolve into a designer, and it refuses to dissolve into accident either. It is too exact for that. Which leaves the question underneath all of it, and it is stranger than it sounds. Whose behavior is the death grip? Not what causes it. Whose is it? Everything about it is done by the ant's body and serves nothing in the ant's life and answers entirely to the fungus. The act belongs to one creature, the body performing it belongs to another. The biologist whose thinking has shadowed this entire account gave that arrangement its name. Richard Dawkins called it the extended phenotype. The word phenotype is only biology's term for the visible physical expression of a gene, the thing a gene builds. The genes for an eye build an eye, and the eye is their phenotype. The genes for a wing build a wing. Ordinarily, the phenotype of a gene is the body the gene sits inside. The gene makes the animal, and the animal is its expression. Dawkins's argument, set out in a book he gave the subtitle "The Long Reach of the Gene," was that this is too small a place to stop. A beaver's genes do not only build a beaver, they build a dam, a wall of felled trees and packed mud, standing in a river that no beaver carries in its body and every beaver builds, generation upon generation, by an inherited compulsion as much a product of beaver genes as the beaver's own teeth. The dam is a phenotype. It simply happens to be made of wood and water and to stand outside the animal. A spider's web is the same. An organ of silk the spider's genes express in the open air instead of in flesh. The reach of a gene, Dawkins said, does not stop at the skin of the body that carries it. And at the very end of that reach, past the dam and the web, sits the strangest case of all, where the thing a gene builds is not an object, but the body and the behavior of an entirely different animal. That is what the death grip is. It is the extended phenotype of the fungus, a structure the fungus's genes express not in fungal tissue, but in the muscle and the joints and the looping path of a carpenter ant. The climb up the stem is a fungal trait. The turn to the north is a fungal trait. The locked jaw is a fungal organ, built like the dam, out of borrowed material and serving like every phenotype, the survival of the genes that made it. Dawkins put the principle about as plainly as it can be put. A behavior tends, across evolutionary time, to favor the survival of the genes responsible for it, whether or not those genes happen to sit inside the body actually performing it. The genes for the death grip are in the fungus. The body performing it is the ant. The grip favors the fungal genes, and so the grip endures. The paper that first measured all that precision, the heights, the bearings, the angle of the sun, knew exactly what it was looking at and said so in its title. It called the dead ant the expression of an adaptive, extended phenotype. The dead ant is not a bystander to the fungus. The dead ant, fixed in the posture it died in, is the fungus's body, finished and on display. This is a strong claim, and the people who make it are careful about when they are entitled to. Not everything a sick animal does is the extended phenotype of its parasite. Some of what we watched in the ant's last day, the stumbling, the falling, may be no more than a body coming apart, sickness rather than instruction, and to call that an extended phenotype would be to read authorship into simple damage. The grip earns the name for one reason. It can be shown to be an adaptation of the fungus, shaped by selection acting on fungal genes. We know this from the test that has run quietly through the whole account. Move the body out of its narrow band and the fungus fails. The position is not incidental. It is precise because precision in the placing was selected for, in the fungus, across an immensity of time. A trait you can break by moving it, and that costs the parasite its entire future when broken, is a trait selection shaped the parasite to produce. That is the line between an extended phenotype and a mess, and the death grip falls cleanly on the side of the phenotype. Which brings the long argument of these chapters to its point, and lets us finally say something honest about the word we keep tripping over: design. We have refused it this whole time, swapping it out for clumsier phrases, and it is worth saying why, because it is not fussiness. To call the death grip a design is to smuggle, in a single word, a designer into the room. Someone who wanted it, intended it, made it for a reason. There was no one. What there was instead was reach after blind reach, countless fungal lineages whose genes reached out into countless ants and mostly reached badly. Walked the host to the wrong place, bit at the wrong hour, missed altogether, and died leaving nothing. The few whose reach happened to land well left more fungus behind them. The ones after those reached a little better still, and the failures, in numbers beyond imagining, simply vanished and took their genes out of the world. What remains at the far end of that deletion is a reach so well aimed that it looks authored. The appearance of design is not the trace of a designer. It is the residue of everything that missed. We drop the word not out of pedantry, but because the word is, quite precisely, a lie about how the thing came to be. And once you can see the reach, it becomes difficult to stop seeing it, including much nearer than a rainforest. You have an extended phenotype too. The room you are lying in was warmed by it, by genes, in you and the long line behind you that build the kind of animal which makes shelters and lights fires and holds heat against the dark. The walls and the warmth are an expression of your inheritance as surely as the dam is of the beavers. The words you are following right now, the paths worn through the places you live, a thing built or planted or taught to a child, all of it is your genes reaching past your skin into the world, exactly as the fungus reaches past its own. And the symmetry runs deeper than its comfort might suggest. The ant is a vehicle, a body a passenger's genes are using to reach the next generation. So, in the plainest biological sense, are you the vehicle your own genes ride in, not the passenger you take yourself to be? The one difference, real and enormous, is that your genes ride inside the body they are steering, while the funguses ride in a body that was never theirs. The principle is identical. The reach is identical. You are only, for once, seeing it from the inside. If that reach were a freak, a single bizarre trick the fungus alone had blundered into, it would be easier to hold at arm's length. It is not a freak. A reach this useful is something selection arrives at more than once in lineages that never touched and never will. Somewhere tonight, on a blade of grass in a cooler country, another ant is climbing toward the tip and clamping down for the night, going nowhere of its own choosing, waiting to be eaten. And the thing that put it there is not a fungus at all. It shares not a single cell with one. It has reached into the ant by a wholly different road, for the same blind reason, and it has arrived at very nearly the same answer. The ant on the grass blade is a wood ant, in a meadow somewhere in the cool, temperate world, and what it is doing looks, at a glance, like the very thing we have been watching all along. As the evening cools, it leaves the ground, climbs a stem of grass nearly to the tip, and bites down, locking its jaws on the blade, and there it holds through the cold of the night. But watch it past dawn, and the resemblance breaks. As the sun warms the meadow, the ant lets go. It climbs down, spends the day as an ordinary ant among ordinary ants, and when the evening cools again, it climbs back up and clamps on once more. It is not dying. It will do this for days, night after night, alive the whole time, because the thing steering it does not need it dead. It needs it eaten. Inside that ant is not a fungus, but a flatworm, the larva of the lancet liver fluke, whose adult form lives in the liver of sheep and cattle and deer. The fluke faces the oldest problem in this whole story, told in a different key. It has to get from a small animal that grazers ignore into the gut of a grazer that will carry it onward. Its answer is to put the ant where a grazing mouth will find it, up at the tip of the grass, at dawn and dusk when the cattle feed, clamped in place and waiting. To manage this, one of the flatworm larvae crawls up into the ant's head and settles in a small knot of nerves there, the cluster that works the jaws, and from inside the nervous system, by means no one has yet worked out, it takes hold of when those jaws close and when they open. A fungus that walks an ant up a stem and locks its mouth by going around the brain entirely. A flatworm that walks a different ant up a stem and locks its mouth by burrowing straight into the nerves. The same act, built by two creatures that have not shared an ancestor since before there were animals with nervous systems at all. Once you have seen it twice, you start finding it everywhere, and that raises a question worth sitting with. Manipulation like this is not a simple trick. It is baroque, specific, improbable, The kind of thing you might expect a lineage to stumble into once in the history of life, if ever. So why does it keep appearing again and again in creatures with nothing in common? Consider a cricket walking on a summer night to the edge of a pond and jumping in. Crickets do not swim, they drown. But coiled inside this one is a hairworm, a creature that can grow to several times the cricket's length, folded up in its body cavity. And the adult hairworm lives and breeds only in water. The worm cannot reach the water on its own, so the cricket carries it there and walks into the pond, and the worm uncoils out of the drowning insect into the pool where the rest of its life will happen. How it turns a land animal's horror of water into a pull toward it is, once again, not understood. The chemistry is suspected and unproven. There is exactly one of these we genuinely understand, and it is worth knowing because it shows what understanding one would even look like. A jewel wasp, a small metallic green thing, hunts cockroaches far larger than itself. It does not try to overpower one. It stings it twice, once in the thorax, briefly, and then a second sting delivered with surgical care directly into the cockroach's brain, into the precise region that governs the urge to walk. The venom does not paralyze the roach, it removes its will to go anywhere. The wasp then takes hold of one of the roach's antennae and leads it, walking docile, unhurried, like a dog on a leash, down into a burrow, where it lays an egg on the living body and the larva eats it slowly from inside. We know how this one works because the wasp does, in seconds with a needle, what the fungus does across 3 weeks with chemistry. It puts a particular cocktail into a particular place in a nervous system. We can watch the needle go in. With the fungus and the fluke and the worm, there is no needle to watch, only an outcome and a mechanism that recedes the moment you reach for it. Lay these side by side, the fungus, the flatworm, the roundworm, the wasp, and the spread of them is the whole point. These are not near relatives sharing a family trait. A fungus is no closer to a flatworm than it is to you, which is to say, not close at all. Their lines parted around 1 billion years ago, before anything on Earth had a body. A wasp and a single-celled parasite last shared an ancestor even longer ago than that, when all of life was a smear of cells. They hold no machinery in common, inherited no manipulation from any shared source, copied nothing from one another, and each separately, on its own line, reached into the behavior of another animal and turned it away from that animal's own survival and toward the parasite's spread. If a designer had made one of these, you would expect the same signature on the rest, one solution reused. Instead, you find the same solution invented from scratch, over and over, in lineages that could not possibly have shared it. That is not the fingerprint of a designer. It is the reverse. It is what the world looks like when one recurring problem, get from a small host into a larger one, keeps meeting the same small handful of answers that happen to work, and selection, blind and everywhere at once, keeps finding them. One of those answers may be inside you as you listen. There is a single-celled parasite called toxoplasma that finishes its life only in cats, but spends part of it in other warm bodies. And in a rat or a mouse, it does something that should sound familiar by now. It takes the animal's most basic, life-saving fear, the rodent's hardwired terror of the smell of a cat, and quietly switches it off, turns it even towards something like attraction, so that the rodent drifts toward the cat, and the cat eats the rodent, and the parasite goes home. Rodents are not the only warm bodies it reaches. People are full of it. Across the world, something like 1/4 to 1/3 of all human beings carry toxoplasma, most without the faintest idea, picked up from a cat or from undercooked meat and settled in for life, including, in a great many of them, as small dormant cysts seeded quietly through the brain. There may be one in yours, And here we have to be careful, because this is exactly the kind of fact that gets carried far past what it can bear. The headlines write themselves: a mind control parasite, rewiring human behavior, making us reckless. The honest picture is much quieter and much more interesting. When researchers have looked hard, followed large groups of people for decades, tested whether infection tracks with personality or risk-taking or anything else, the strongest studies have found essentially nothing. The cysts sit there. As far as the best evidence can tell, they do not move you. Even the famous effect in rodents is now argued over. Some researchers suspect it may be less a precise switch thrown on cat fear than a general blurring of fear, a side effect of inflammation rather than a tailored act of control. The parasite is real. The cysts are real. The reach into the rat is real. And whether anything reaches into you is a question the science has so far mostly answered with a no. That gap between what the parasite plainly does in a mouse and what it plainly does not do in you is the honest edge of all this. And it is worth more than the headline ever was. Step back, though, from any single one of them and notice what the sheer commonness of manipulation means. A trick this useful, arrived at this many times, is not rare. It is a whole way of making a living, practiced across the living world by things that have never met, and anything that becomes that common, that successful, becomes, by the very same logic, a resource. A manipulated host is a concentration of stolen energy and a future laid out in advance. A reliable manipulator is a reliable, repeating event in the forest. And in nature, nothing reliable and full of energy stays unclaimed for long without something arriving to take it, including, as it turns out, the manipulator itself. We have been telling this story as though the fungus were the top of it, the manipulator, the controller, the thing with the upper hand over an ant and, through the ant, over a patch of forest. It is worth correcting that now, because it is almost exactly wrong. The fungus is not at the top of anything. Go back to the dead ant under its leaf, the body locked in place at the cost of 3 weeks of patient work, and look at the stalk rising from the back of its head. That stalk is what all of it leads to. The spores fall from there, and the spores are how the fungus reaches a next generation. And on a great many of those stalks, you will find something else growing. A pale, soft, cottony white, spreading over the dark fungus like frost creeping over a twig. It was given a name only a few years ago, Niveomyces, from the Latin for snow white. And what it is doing is eating the manipulator alive. It is a second fungus, a parasite of the first, and it specializes in precisely this, colonizing the fruiting body of the zombie ant fungus and shutting it down before it can reproduce. It does not touch the ant. The ant is already dead. It castrates the killer. The white fungus spreads over the stalk and the spore-bearing structures and sterilizes them so the spores never form or never ripen or never fall. And the whole elaborate sequence, the infection and the occupation and the long walk to the perfect leaf and the locked jaw, ends right there, with nothing released and nothing passed on. When researchers in Brazil went through the graveyards and counted, the numbers were stark. Of the dead ants they examined, more than half, around 55 in every 100, had been overtaken by hyperparasites like this one. And of all the fungal fruiting bodies, only about 6 or 7 in 100 were managing to release spores at all. Turn that over for a moment. The fungus succeeds at everything we have spent this story admiring. It finds the host, hollows it out, walks it to the exact right place, builds the grip, and then, something like 14 times out of 15, it never releases a single spore. You might expect the ants to be the source of that failure. A colony fighting back, scouring the infection out of itself. They are not, or not in the way you would imagine. When researchers watched closely, they found that the colony does not register an infected nestmate as a threat at all. An ant filling up with fungus is groomed and fed and treated as family right up until the day it leaves, because nothing about it reads as wrong. Most of these carpenter ants do not even carry the antiseptic gland that many other ants use to scrub fungal spores off themselves and one another. That particular weapon the colony simply does not have. So the fungus is not defeating a defense, it is slipping past the place a defense would be. And it does that in part with the very thing we watched on the ants last day. By driving the host out of the nest to die alone in the understory, it stages the whole vulnerable business of dying and fruiting somewhere the colony's housekeeping never reaches. And yet the colony, taken as a whole, is fine. Over 20 months of watching nests in the Brazilian forest, every single colony had infected dead lying nearby. The pressure was constant, a new body or two appearing most months, and in all that time, not one colony died of it. The relationship is old and settled and chronic, more like a low fever a body carries than a wound that kills. The reason is that the true host here is not the ant, it is the colony. A carpenter ant colony is tens of thousands of bodies behaving as one, and it can lose a forager or two a month, year upon year, the way you lose skin cells. The losses fall on the expendable. The old foragers near the end of their use, the ones whose work has already carried them out to the dangerous edges of the colony's world where the infection waits. The core of the colony goes on untouched. The fungus takes its small, steady tax. Neither side wins. Neither was ever going to. Which is the quiet correction this chapter has been making to everything before it. We have spent 8 chapters on the fungus's precision, and the precision is real, but precision is not the same thing as control, and the fungus controls almost nothing that finally matters. It cannot overcome a colony. It cannot keep its own body from being eaten. Most of the time, it cannot even reproduce. A designer setting out to build a manipulator would build one that worked, that reached its end reliably, defended its own offspring, sat secure at the top of its small world. What is actually here is leaky, half-castrated, evaded and preyed upon, succeeding just often enough to carry on and no more. That is not a flaw in the design. It is the absence of a design. It is what every so-called controller in nature turns out to be on close inspection. Not a master at the top of anything, but one more participant in a tangle of things, using and being used, none of them in charge, the whole arrangement held in a rough and temporary balance by nothing but the sum of everyone's failures. That tangle is not off in some far rainforest. It is in your gut right now, running at a scale that makes the forest floor look quiet. The bacteria you carry, that resident population you met a few chapters back, are themselves hunted in their countless billions by viruses called bacteriophages, which do nothing but break into bacteria and burst them open. There are more of these tiny bacteria killers inside you than there are stars in the galaxy by a wide margin, and they are, this very second, parasitizing your parasites in a war with no top and no end. The parasite's parasite is not an exotic discovery brought back from the tropics. It is the basic shape of life, and you are partly made of it, and none of it is new. Not the fungus, not the white thing eating the fungus, not the endless nesting of one creature inside the next. It is, in fact, almost unthinkably old. The arms race we have been watching in a present-day forest was already ancient when our own kind of animal was nothing more than a small, nervous shape in the dark. To see just how far back it runs, we have to leave the living forest altogether and go looking in stone. In a disused pit near the village of Messel in Germany, the ground is made of a fine, dark shale that was once the floor of a still lake. A lake so deep and so airless at the bottom that whatever sank into it was not torn apart by scavengers or stirred by currents, but simply pressed, layer on layer, into the rock and kept. People have lifted extraordinary things out of that shale. Whole early horses no bigger than a dog, birds and bats with their final meals still inside them, insects that kept the color of their wings. And among all of that, someone found a leaf. A single fossil leaf, around 48 million years old, with a row of small marks cut into the tissue along its veins. The marks have a particular shape, a double scar, like a tiny dumbbell, the print left by two mandibles closing on a leaf and biting down hard. There are 29 of them, gathered on the main veins in exactly the pattern a carpenter ant makes when the thing inside it walks it to a leaf and locks its jaws. The ant is long gone. The fungus is long gone. What survived, pressed into stone for 48 million years, is the bite, the behavior itself, the death grip, fossilized as an act. It is worth being honest about how rare a thing that is to have at all. A fungus is soft and rots in days. An ant is small and fragile and vanishes almost as fast. Across the whole history of this manipulation, the number of moments that happened to fall into the exact circumstances that preserve them, an airless lake, a flow of tree resin, the one accident in a billion that turns a death into a record, is vanishingly small. We hold a handful of frozen instants and almost nothing in between. The countless ants that climbed and bit and were eaten or rotted away across the eons left no trace whatsoever. What we have is not a film of the past, it is a few stills scattered across an immense darkness, and from those few stills we have to read the whole. A few of the stills are older and stranger than the leaf. In amber, fossil tree resin, which traps and keeps soft things the way shale cannot, researchers have found the fungus itself. Not the bite this time, but the body. An ancient relative of our fungus caught in the act of erupting from its host, its stalks frozen mid-growth out of a dead insect and sealed in golden resin for around 99 million years. One was growing from a scale insect, and then, only recently, two more were described from the same Burmese amber, one of them rising out of an ant, a young one still in its pupa, and one out of a fly. Stop on that date for a moment. 99 million years ago was the middle of the age of the dinosaurs. There were no people, no primates, nothing remotely like us. The flowers were new and the grasses had barely begun. And already, in that world, a fungus was doing this, growing out of the heads of insects exactly as it does tonight in a forest in Brazil. It is not a recent arrival. It is older than almost everything you would think of as familiar life. Trace the lineage back further still by reading the molecular differences between the fungi alive now, and it appears to reach down towards something like 130 million years, and to begin somewhere unexpected. The ancestors of the zombie ant fungus did not start on ants at all. They were parasites of beetles, of beetle grubs in soil and rotting wood, and they manipulated nothing. They simply fed and killed. At some point, that beetle-eating lineage made the jump onto ants. And it was that jump, the new host, and the manipulation that came with it, that seems to have lit the fuse, sending the lineage radiating out into the hundreds of separate host-locked species alive today, one fungus very nearly for every kind of ant the lineage settled onto. The whole Baroque performance we have followed is a late flourish on the end of a long, plain history of killing beetles in the dark. You do not need a pit in Germany to hold a record like this. You are one. The machinery you are running on as you lie here, the code your cells are reading this very second to assemble their proteins, and the molecular tools that read it, is itself a fossil, far older than the fungus's whole 130 million year story, a cipher that settled into place billions of years ago in the first cells, and has been copied forward without a real break ever since, through every ancestor you have ever had. The fungus's lineage is a recent branch on that record. So is yours. You and the ant and the fungus are reading the same ancient code right now in the same letters, inherited unbroken from the same deep source. And the only reason any of the three of you are here to do so is that the line of copying never once failed in any of you across all that time. The deep record holds one more thing worth seeing, because it shows the blind hand at work twice over in the same lineage. In the tropics, where the leaves stay on the trees, infected ants bite the undersides of leaves, as they have done ancestrally for tens of millions of years. But in the cooler forests, in parts of North America and quite separately in Japan, the ants do not bite leaves. They bite twigs and bark. The reason is the seasons. In a forest where the leaves fall every autumn, an ant clamped to a leaf would drop to the ground with it long before the slow fungus could finish, and the lineage would end there. Clamp to a twig, and the body stays put through the winter. So in two separate parts of the world, with no connection between them, the same problem, falling leaves, produced the same answer. The shift from leaf to twig arrived at twice over from nothing. The same logic ran across whole kingdoms in the fungus and the fluke and the wasp. Here it is again, in miniature, inside the history of a single fungus. Not a plan reused, but the same pressure meeting the same solution, wherever it happens to come up. All of it, the 130 million years, the beetles and the ants, the bite pressed into stone, the code running unbroken in your cells and the funguses alike, sets up one last fact, the strangest of all, and you can feel where it points just by noticing the warmth of your own body in the dark. In all that time, across all those hosts, beetles, ants, flies, scale insects, an entire deep history of riding other lives, this fungus and its kind have never once made the leap to anything like you. Never, in all those millions of years, to a single warm-blooded thing. And the reason they never have is not buried in the deep past at all. It is right here, in the heat coming off your skin this very second. The heat coming off your skin is the most boring fact about you, and it may be the one keeping you human. Your body is holding itself right now at very close to 37 degrees, a little under 100 on the Fahrenheit scale, and it has held there within a fraction of a degree every hour of your life, awake and asleep, summer and winter, whatever the world outside has been doing. You spend a large share of all the energy you take in simply keeping that furnace lit. It feels like nothing. It is just how warm you are. But to the kind of organism we have spent this entire story inside, that warmth is not nothing. It is a wall. Most fungi are creatures of cool, damp, moderate places. The forest floor, the rotting log, the shaded understory where the ant was walked to die, held at the gentle mid-20s where a fungus thrives. Push the temperature up and they begin to fail. There is a rough figure for how fast. For every single degree you climb through the 30s, you lock out something like another 6% of all fungal species, until, by the time you reach the heat of a mammal's body, almost none are left that can grow there at all. A human being is, to very nearly every fungus on Earth, an oven. And this is not a small fact about life. It is one of the reasons your kind of animal lives the way it does. Plants drown in fungal disease. Insects are riddled with it. We have spent 11 chapters on one spectacular example, and there are thousands more. Cold-blooded animals, frogs and snakes, are dying of fungal plagues around the world as we speak. Mammals, by comparison, walk through the same spore-thick air almost untouched, carrying inside us a heat that the things which devour the others simply cannot survive. This is the part worth saying plainly, because the fear has a famous shape now. There is a story, a very good one, a game and then a television series, in which a fungus exactly like this one, a cordyceps, mutates, crosses into people and ends the world, turning humanity into a shambling forest of the infected. It is gripping and it is fiction, and the scientists who study these fungi for a living are quite calm about why. To make the leap from an ant to a human, a fungus would have to do three impossible things at once. It would have to cross one of the widest gaps in all of biology. These fungi are so narrowly tuned that a species fitted to one ant often cannot infect the ant nesting in the next tree, let alone an animal as utterly unlike an ant as you are. It would have to learn to grow in heat that currently kills it. And it would have to do both, not in the few years a story allows, but across the tens of thousands or millions of years that real evolution takes to remake a body that thoroughly. The thing that scripts an ant's last afternoon cannot script yours. It is nowhere near able to, and will not be within any span of time that has the word soon anywhere near it. But here, a careful mind has to catch itself, because there is a tempting and wrong way to say all of this. It is tempting to say that we evolved our warmth in order to keep the fungi out, that the heat is our shield, raised against exactly this enemy. It was not. Warm-bloodedness is an old and costly thing, and the reasons it arose are tangled and still argued over. The power to stay active in the cold, to run and hunt and think through a freezing night, to hold a steady inner world, whatever the weather outside. Whether shutting out fungal disease was ever one of the pressures that favored it is a genuine and open question, a suggestion some researchers make and others doubt. At most, one quiet thread among several, and never a design. The wall was not built against the death grip. The heat is here for its own tangle of reasons, and it happens, as a side effect, a piece of luck you did nothing to earn and no ancestor acquired on your behalf, to be lethal to the very things that would otherwise be walking your body off somewhere to die. You are defended by an accident. It is no less a defense for that. And yet, it would be a comfortable lie to leave it there, with you safe behind your heat, because the truth is that manipulation does reach us. Only not by this road. There is something that takes the behavior of a human being and bends it, precisely and reliably, toward its own spread, and it has been doing so for as long as there have been people to do it too. It is rabies. A bite from an infected animal puts the virus into a wound, and from there it does something patient and terrible. It climbs slowly up the nerves themselves, using the body's own wiring as a road, the way nothing else in this whole story has, traveling inward along the nerve fibers toward the spinal cord and the brain. When it arrives, it settles into the oldest, deepest regions, the ones that govern fear and rage and drive, and from there it begins to rewrite the animal. It fills the body with a horror of water, until swallowing becomes impossible. It floods the mouth with saliva. And then, at the precise moment that saliva is thick with virus, it turns a frightened, ordinary creature toward aggression and biting, so that a single bite carries the virus into the next body, up the next set of nerves, on and on. That is not a fungus, and it is not an ant. That is a parasite reaching into a human nervous system and turning a person into the thing that spreads it by exactly the kind of blind, authorless process we have watched all along. No malice in it, no plan, only a virus shaped the way everything in this story is shaped. The strains that drove their hosts to bite left more copies of themselves than the strains that did not. So the reassurance is real, and it is worth holding on to as you lie there in the warm. The elaborate, patient, almost beautiful horror of the death grip will never be yours. The wall holds. You are the wrong temperature to be a stage for it, and you always will be. But the larger thing this story has been circling is not whether one particular fungus can reach you. It is that you were never standing outside the story to begin with. Manipulation, parasitism, one life reaching into another and bending it to its own ends. These are not strange events at the far edges of nature, happening to ants in distant forests. They are the ordinary weather of being alive, running through every body that has ever lived, including the one you are lying in. And if you trace it all the way down, past the rabies and past the heat, into what your own body is actually made of, The line between the host and the parasite, between the self and the thing that uses it, turns out to be far stranger and far older than anything a fungus ever did to an ant. As you lie here in the dark, somewhere it is the middle of the afternoon, and it is happening again. In a forest, a long way from you, an ant is walking a trail it has walked 100 times, carrying food back toward a nest high in the canopy, one worker among thousands with no idea that anything at all is wrong, and on the side of its body, far too small to see, is a single spore. We have followed one of these ants a very long way tonight, down into its blood and up onto the underside of a leaf, into the locked jaws and the untouched brain and the chemistry that no one can name. Out across whole kingdoms of other manipulators that arrived at the same answer alone. Back 130 million years into amber and into stone, and at last into the warmth of your own body, the one wall this thing has never learned to climb. It is worth coming back at the end to where it started, to the ant on the trail which knows none of it and is simply going home. So let us be honest finally about what all that following did and did not teach us. There is a great deal we can now say with real confidence, and it is worth saying slowly. We can say that this is old, that a fungus was growing out of the heads of insects before there was a flower on earth worth the name, and that the bare act of steering an ant to its death has lain pressed into rock for 48 million years, waiting for someone to recognize it. We can say that it is not a freak and not unique, that the same blind answer has been arrived at again and again by creatures sharing nothing but a problem, because the problem keeps coming up and the world holds only so many ways to solve it. And we can say what the death grip really is, which is the thing it took the whole night to earn. It is not a behavior of the ant, it never was. It is the body of the fungus, grown out into the world in borrowed muscle and bone, a handful of genes reaching past the small life that carries them and closing a jaw that is not theirs, on a leaf they will never see, for reasons the ant has no part in. Everything that looked like design in it is real as a pattern and false as a story. There was no designer, there was only an unimaginable depth of time and a process that kept whatever happened to work and quietly erased everything that didn't, until what was left was a thing so well shaped that we cannot look at it without reaching by reflex for the word made. And we can say too that this exquisite ancient borrowed body is the master of almost nothing. It is castrated more often than not by a fungus of its own. It is slipped past, outlasted, eaten. It hangs on by the thinnest of margins, one more player in a tangle where no one holds the reins. And then there is what we cannot say, which turns out to be the steadiest part of all. We cannot say how it is done. After all of it, the genome read end to end, the body sliced into 1,000 sheets and rebuilt 15 years of careful people in the leaf litter, we still do not know which molecule or which crowd of molecules reaches into a muscle and holds it shut. We do not know how a thing with no nerves of its own can steer an animal's whole body without ever once touching the place that body keeps its mind. We do not even know for certain how much of what we watched was steering at all, and how much was only a small creature coming apart as it died. The most studied behavioral parasite on the planet still keeps its central secret. There is something steadying in that, if you will let there be. We have not run out of world. The oldest, simplest-looking things are still, at their very center, genuinely unknown. And that is not a failure. It is the size of what is left, none of which the ant will wait for us to settle. While we have been talking, it has reached the place the spore needs it, or it has not. Somewhere a stalk is pushing out of a dead ant's head into the understory air. Somewhere a soft white fungus is creeping over that stalk to sterilize it before it can scatter a single spore. Somewhere a colony of tens of thousands is carrying on, spending its old foragers and keeping its core, paying its small, steady tax to the forest and surviving as it has every month for longer than there have been people to count the dead. All of it is running tonight, exactly as it ran 100 million years ago, wholly indifferent to the fact that, for the first time in all that time, something has begun to watch it and try to understand. The story is not finished. It is only for tonight as far as we have come. But there is one last turn, and the whole night has been leaning toward it. You have listened to all of this as though it were a story about something else, about ants, about a fungus, about the strange business at the far edges of nature. It was never about something else. The line we kept circling between the host and the parasite, between a body and the thing that lives inside it and uses it, runs straight through you, and it is older and stranger than anything the fungus ever did. Consider for a moment what you actually are. In every cell of your body, powering every breath and every small movement you have made tonight, sits a structure that was once a free-living bacterium, swallowed whole 2 billion years ago by one of your single-celled ancestors, and never broken down, never expelled, kept instead until its descendants became the very part of you that turns food into the strength to be alive. You did not inherit that from some pure and original version of yourself. You inherited a truce, struck so long ago that the two old enemies have forgotten they were ever two. And it runs deeper into you than that. Something like 1 part in 12 of your entire genetic inheritance, the text that built you, that you would hand on to any child you ever have, is not yours in any first sense at all. It is the wreckage of viruses, ancient infections that drove their own genes into the cells of your ancestors so deeply that they were copied down the generations long after the viruses themselves were dead and gone, until they were simply part of the book. You carry the fossils of old plagues written into the line that makes you. And here is the strangest fold of all. One of those captured viral genes, somewhere far back along the mammal line, was taken up and put to work to help build the placenta, the organ that lets a mammal grow another mammal inside its own body and bring it into the world alive. The thing that let your mother make you began as a virus. The deepest machinery of being a mammal is, in part, an invader that was caught and kept and turned to use. So the question the fungus raised all the way back at the beginning, whose body is this, the host's or the parasite's, does not come back with the clean answer we wanted. You are not a fortress with parasites at the gate. You are the peace that was made. You are what remains when 1 billion years of invasions stop being wars and settle, at last, into one working body. A coalition of the captured, most of them so old and so quiet that you have never once felt them in there. The fungus and the ant are one end of that long story, the end where the reaching in still kills. You are the other end, the end where somehow it became simply life. Sit with the whole shape of that for a moment, because it is the thing worth carrying out of tonight and into sleep. A process with no mind, no aim, and no author, running for nearly 4 billion years, keeping whatever chanced to work and discarding the rest, with no notion that it was doing anything whatsoever, produced the death grip, which looks for all the world like a plan and is not one. And the very same process, by the very same blind means, produced the thing that is, this moment, lying in the dark and understanding that it did. It produced a mind. It produced the one part of itself that can turn and look back along the entire length of what made it and ask what any of it was for. The process has no answer because the process was never asking anything. The meaning was never out there in the 4 billion years. The meaning is the asking. And the asking is the newest thing the old blind process has made, and you are it. That is not a reassurance. It is something better and quieter than a reassurance. It is a place to stand. There is a name here for the thing all of this hangs from, the thread. The single unbroken line of inheritance that runs from the first living cells through every ancestor you have ever had, every fish in its drying pool, every small warm thing in the dark, every captured bacterium and quieted virus along the way, down to the body you are lying in tonight. It has never once broken. Not in 4 billion years, not at any death along the way, because every ancestor you have lived long enough to pass it on. That is not remarkable. It is the only history you could possibly have, and the thread carries everything that was ever taken in and kept. It carries the ant in its way. It carries the fungus, and it carries you at its furthest reaching end. You do not have to hold any of it. The thread holds itself. It always has. The ant is going home. The fungus is doing the only thing it knows. The 4 billion years are behind you now, quiet and complete, having arrived for the moment at you. Nothing more is being asked tonight. Let your jaw go loose. Let the warmth stay where it is. The thread continues, with or without your watching it, and you are at its current end, and that is enough. Rest now.